Hey guys, in this video, we're going to talk about graphing circles. We're going to focus on using general conic form and standard form of a circle. So first I'm going to talk about where these forms come from, and then I'm going to do 3 examples. Let's get started. Okay. Graphing circles, or circles in general, are part of a group of equations called conic sections. And essentially, all they are is slicing up a cone. So, for example, if we slice a cone up at this angle, and we do that in like this kind of hourglass setup, we create a hyperbola. If we set it up here where I guess we could say it only appears in one cone, we call that a parabola, which you guys know to be a quadratic. Then we have a circle here, which is slicing directly across the cone. Now, there's a couple of things going on here. So when we look at circles, what we're looking at is this cross section of a cone, kind of like this. Now, what I could do is I can slice this cone anywhere. So I could actually create almost an infinite amount of slices inside the cone. Now that's a little bit beyond what we're talking about here in this video, but it is the introductory to these concepts. So it's just kind of quickly worth talking about. Now, the circle and in all conic sections, they come in 2 forms. They come in what we call in this case a standard form and a general conic form. A quadratic also has these forms. We call it here vertex form, and then here we call it standard form. Why the names are different, I'm not quite sure. But essentially, the standard form of a quadratic is a general conic form, and the vertex form, which some of you guys might be familiar with, is really the standard form of the conic. Alright, let's take a look at one more thing. I created 2 examples here of standard form and general conic form, and let's just take a second and graph them. So I typed the first part of the equation, and you can see that we started creating a parabola. And the reason why I did that is I just want you to be able to see how what we're doing is related to other maths that you have probably done. This stuff is all interconnected. Nothing here is isolated as it may appear. Now, once I finish the equation, the circle appears. That's that part. What I could do is I could change these signs here just for starters, and I could start to move my equation around, or my circle around, just a little bit. So I'm just kind of demonstrating by changing some simple things here quickly, just so we could see how I could alter the size of the circle by just manipulating the equation. Now let's enter the general conic. So if you look at the general conic form that I wrote here, I decided to write the A and B, which is not typically written when we talk about the general conic form of a circle. But the reason why I chose to write that in there is because all the conic forms kind of resemble this general conic form in some way. So let's take a look at how that looks in Desmos. So if you see, the circle that was once red is now blue, and that's because these 2 forms are producing the same exact circle. Now, I could actually change some shapes here. So if I take this and make this a minus, I changed the equation into a hyperbola. Notice, by the way, how it's kind of tangent with the circle. That's not a coincidence. And if you notice, as I just make minor changes here, I am significantly changing the way the shape appears. Now, I could do the same with the general conic form. So I can change this to a minus, creating that hyperbola again. I can add a coefficient, creating an ellipse. I can move positions by changing these signs. And it just manipulates the shape. So this is a form of algebra where we can manipulate something physical with some equations. Now let's take a look at a few examples. For all the complicated discussions, the examples are actually not that bad. So let's get started. I have to graph this, and we discussed how we have the standard form of a circle, and that's what we have here. It isn't any wizardry, but essentially, since I have a -2 in for h, it is a +2, because it takes a positive and a negative to maintain this negative here. Then this positive here creates a -1 because k is negative. So that means I would need another negative to make that positive. The other way to look at it, if you really want to, you guys know how I like some side notes if you watch my past videos, is I could separately set these like equal to 0 and add 2 to both sides and kind of create that situation just like we did with the quadratics. But we're not going to do that here. R squared is 25. So what I have to do is I have to square root both sides to get to the radius, which is 5. And now I can just graph it. I try to tell my students that there is no benefit in creating a work of art here. So I graphed the center of the circle to -1. And now what I'm going to do is in every direction, I'm just going to count up. 1, 2, 3, 4, 5. Then I'm going to count left. 1, 2, 3, 4, 5. 1, 2, 3 down. And 1, 2, 3, 4, 5 to the right. I usually put like these little flat spots there. They kind of help me make a circle. But I'm by far no pro. And now what I'm going to do is kind of just try to create that circle. And as you can imagine, this is amazingly difficult to do with this glass top and this pen. I do mention that if you have a compass, this is a great time to put that to use so that you can create nice perfect circles. But that's it. That circle is graphed. Let's take a look at the next example. In this example, we have to convert to general conic form. So let's start with getting us into standard form. The center is -2, 4, and my radius is 3. By getting the coordinate of my center, which is -2, 4, then I count. So I can count up 1, 2, 3. I could also count in any direction, so I can count to the left. 1, 2, and that is my radius. Now what I'm going to do is I'm going to place that into standard form. So since that's a negative and negative make a positive, so that's x plus 2 squared. Then that's a positive 4, so that stays y minus 4 squared. Then 3 squared is 9. Now I'm going to start the process of converting it to general conic form. The first part of the process is to expand these squared terms and then distribute them. So I am opening up these polynomials by writing them twice. Now I am going to distribute. I actually have a video on how to distribute polynomials, and you're welcome to check it out. Or, as I always say, you can watch the multitude, infinite amount of videos on distributing polynomials on the interweb or the YouTube. But I am essentially just following that procedure as I am talking to you to create this long aneurysm inducing thing here that's eventually going to condense. So now let's go to the next step now that I have distributed both polynomials. What I am going to do is I'm going to look for like terms to combine again, and that's these two constants. So now I'm going to start to shrink this down a little. The 4x will not combine with anything else. The y squared will not combine with anything else. But I have plus 20 here. Okay, I'm done the hard part. There's just a few more steps. General conic form is set equal to 0, so I have to subtract 9 on both sides. So now I'm going to get x squared plus 4x plus y squared minus 8y plus 11 equals 0. Okay, let's take a quick look. So when we look at the original general conic form, you will notice that it's kind of in this xy order, then a constant. Well, that's all we need to do here, is we just need to rearrange this. So I am going to rearrange this so that it is an x squared plus y squared plus 4x minus 8y plus 11 equals 0. My opinion, and if you've watched these videos before, you will know what I'm going to say, but I feel that we do a better job of understanding math when we don't try to memorize it, but try to understand how things work. And one of those things to recognize is that all the general conic forms will be in this x squared, x, y constant format. So that is general conic form there. Alright, let's take a look at the next example. In this example, they want us to graph this equation. Well, the only way I know to do that without using a graphing utility is to convert it to standard form. It is essentially, well, it is exactly the inverse of what I did before. And now I'm going to get started by first grouping my terms together. So instead of this xy order, I am placing everything in groups. Now what I need to do is prepare my equation to complete the square. If you need to know how to complete the square, you can check out my other video or watch, I'm sure, the endless options of completing the square videos on the YouTube or somewhere else on the internet. So now I am completing the square. I am dividing my b term by 2 and then squaring it. So that's plus 4. I am dividing this term by 2 and then squaring it. 8 divided by 2 is 4. 4 squared is 16. I have to do that on both sides to keep equality or to maintain equality. Now what I'm going to do is I'm going to factor. What multiplies to 4 and adds to 4? That answer is 2 and 2. Okay, what multiplies to 16 and adds to 8? That is 4 and 4. And now I could even add the other side. So 16 plus 4 is 20, minus 11 or plus negative 11, and that would give me 9. And now I could just put it together. Essentially the opposite of what I have done before. Now I have to pull out my center and the radius. Okay, so the center is -2, -4. And my radius, which is 9 square rooted, is 3. Okay, let's graph this. So -2, -4 is down here. And now I am going to count up 3. 1, 2, 3. Left 3. 1, 2, 3. Down 3. 1, 2, 3. And right 3. 1, 2, 3. Create my circle the very best I can. I am a struggling artist, but one day I will make it. Okay, so there we go. Something like that. And there's my dilapidated circle. But that is how we work general conics. In this case, specifically circles. Relatively speaking, these rules do not change from all the conics, so you could just kind of use this process. Hopefully, you guys have found this video helpful.